हेलो।
ब्लैक एंड व्हाइट क्यों?
हाँ, आज ही ब्लैक कर दिया मैंने,
क्यों?
ऐसे ही चेंज के लिए।
अजीब सा लगा।
अभी देखना, लिखने में सही
शुरू में
लगेगा।
बोला था आपको बहुत
हम्म।
एस्थेटिक लगता है, बट शुरू में बोला था, आपने मना कर दिया था।
ब्लैक। देखते हैं, सही लगेगा। हम्म। Today we'll be starting center of mass. Center of mass and rotation. It is center of mass. What it is? What center of mass is? eh, पढ़े। एक मिनट। You okay? Hmm. See, what is center of mass? Center of mass is a point. बड़ा बड़ा क्यों दिख रहा है? Okay. Center of mass is a point where all mass is supposed to be situated in a body. ठीक है, उसे हम सेंटर ऑफ मास कहते हैं। तो ऐसे यहाँ पे कुछ गड़बड़ है। हाँ। Where all mass is supposed to be present. This is known as center of mass. Now, how do we find out the center of mass? That is important. See, the center of mass, the formula is, if there are different masses, like this one, like this is one mass m1,
Taking the center of mass.
this r1 vector.
So,
Huh?
today we are taking center of mass.
Yes, yes, yes.
Um, I've we have completed this one.
You completed this, but
Ah,
we have to complete it now, because without center of mass you cannot start rotation part. It's less only, it's not much. Center of mass part is not much, but the questions are trickier. See, this is x and
funny
y.
questions are there.
Huh?
Like a boy standing on a boat, moving the
Those
boat.
types of questions, yes, yes. See, the now here center of mass is a point where all mass is supposed to be situated in a body, because the mass, if the mass is uniformly distributed, we cannot, it's very difficult to find a point uh, where to apply the force. means it becomes very difficult to apply the force because mass is uniformly distributed where you'll apply mg. That's why for the calculation purposes, what we do, we assume a point where the whole mass of the body is supposed to be situated, and then at that point we apply the force mg like that. So for that purpose, we define center of mass of a body. Now, how to calculate the center of mass? Suppose here there are three different masses. I have taken three different masses, m1, m2, and m3, and according to the coordinate system, they are present as r1 vector, r2 vector, r3 vector. Because you have studied only xy coordinate, I'll write like this: xy1 I cap plus y1 j cap, and r2 vector is x2 I cap plus y2 j cap. R3 vector is x3 I cap plus y3 j cap. In that case, how the center of mass, for this three mass system, how the center of mass will be defined? R center of mass, which is equal to x center of mass I cap plus y center of mass j cap, that is equal to m1 r1 vector plus m2 r2 vector plus m3 r3 vector whole divided by m1 plus m2 plus m3. This is basically sigma mi ri vector I is equal to 1 to n by sigma I is equal to 1 to n mi. This is how you define R center of mass. Okay, one thing. Clear to everyone? It's just basic formula. I'll give you an example on this.
So, what if like the two particles have equal mass? So
No
simple
problem.
formula.
No problem. The center of mass will lie at the midpoint of them.
Okay. So
Masses
it
can
would
be
become
anything
R1 plus R2
by
upon 2,
2.
no?
R1 plus R2 upon 2 it will become. See here, if we further use this one, we can write like this: R center of mass is equal to this. Then we can write x center of mass I cap plus y center of mass j cap is equal to sigma I is equal to 1 to n mi x I cap x I cap plus y I j cap by sigma I is equal to 1 to n mi. So if I compare this I cap and I cap, j cap, these things, this and this, then I can easily write x center of mass is equal to sigma I is equal to 1 to n mi xi by sigma I is equal to 1 to n mi. This is one formula. Also, y center of mass you can write as sigma mi yi I is equal to 1 to n sigma I is equal to 1 to n mi. This is how this will be useful to you, because whenever a system is given to you, three masses are given. Suppose they have asked you to find out the center of mass. Take the case where the Radhika was saying, two masses are there, this mass and this mass. They're actually equal. They said the masses are equal. And the first mass is actually present according to as per the coordinates. This is presented x is equal to x1. Second mass is presented x is equal to x2. Now, where is the center of masses of the system? How we'll do it? We'll use this formula because only x thing is there. Y won't bother. We won't bother because y center of mass, the y coordinate of this whole, the first mass and the second mass is actually 0 because it's lying on the 0, 0, na? So we do not bother finding out the y center of mass. But if we take some other example in which y coordinates were also there, wait. I'll give you one more thing. I'll make it complex. Here origin is here, and let us say about this body. This body, these bodies are present like this, and this is your y. This distance is your y1, and this distance is your y2. This is origin. Let me draw the coordinate axis. This is your x coordinate axis. This is your y coordinate axis. Now in this particular case, we have to find out the center of mass. Then we will be using the formula. How? First, we need to find out the x center of mass. It will be m into x1, m first mass into its x coordinate, plus second mass into its coordinate x2, divided by m plus m. Now we have found x1 plus x2 by 2. This is x center of mass. So the center of mass will be located somewhere on this line, which is at a distance of x1 plus x2 from the origin, x1 plus x2 by 2 from the origin. One thing we have found. Now to find out y center of mass, how we do, y center of mass will be, so first mass is at a distance of y1 from the origin, m into y1. The second mass is at y2. Total mass is m plus m. So it will be y1 plus y2 by 2. So the center of mass of this system will be somewhere here, whose x coordinate is x1 plus x2 by 2 and y coordinate is y1 plus y2 by 2. This is how we calculate the center of mass of a system using the formula. Understood?
Yes, sir.
This is how we make use of this formula. Now I'll be giving you question. This is very simple. Only you have to remember these two formulas. The pink one I have told you. Let me give you some questions. Easy one. And then I'll tell you the uniform mass distribution. That is somewhat difficult. Attempt this. This is easy.
So,
हम्म
equal vector तो मेरा है 3/2 I cap
हम्म
plus half of J cap minus half of K cap.
क्या है एक बार बताना सबसे 3/2
I cap plus
हम्म
half of J cap minus half of K cap.
फिर भी लोग सेम आ रहा है।
एक सेम आ रहा है अच्छा तो ठीक होगा क्योंकि मेरे पास आंसर नहीं है दोनों को सेम आ रहा है तो यही होगा व्हाट अबाउट हरिप्रिया एंड श्यामा
One
हरिप्रिया यू आर गेटिंग सेम आंसर ना
1 minute, sir. I'm finding.
ओके श्यामा व्हाट अबाउट यू
I'm also doing.
do it then in the meantime I'll do one question yes
So you have to multiply the vectors and you have to add it and
yes
divide by total sum.
you
Mass.
have to multiply vectors with the mass individual masses and divide with the total mass that's all
Mhm.
Yes, sir. I got this.
Mm,
but no? Very good.
mm, mm.
Now attempt the second one
Yes, sir. 9/6 I cap. Yes, sir. Yes, yes, yes.
now try attempting the second one
So,
hmm
new coordinates are 0.5 comma 0.7 meter. Like 5/10 comma 7.
0.5 और 0.7 ना ठीक है तो फिर तुमने जो ओरिजिन लिया है वो
Coordinates
1
मान
केजी
लीजिए
1 केजी पे लिया है
1 kg को रिटर्न 0.0.
ठीक है ओके ओके
उसके अकॉर्डिंगली मैंने 2 kg को 1.0 फिर 1.0 और 0.0.
नहीं फिर ठीक है कि वी डू नॉट नो ना
मैंने लाइक स्टार्टिंग से लेना शुरू कर दिया वरना कंफ्यूजन.
हाँ अब देखो डिपेंड करता है अब किसी ने क्या लिया है
बट
तुम
ओवरऑल आंसर तो एवरेज आउट करके ही आ रहा है ना तो यही आएगा.
हाँ ओवरऑल पर वैल्यू डिफरेंट हो जाएगी ना
हाँ वो एक्स वाई कोऑर्डिनेट चेंज हो सकता है.
हम्म
तो अगर ऑप्शन में अगर अगर ये वो होता एमसीक्यू होता
हम्म
तो अगर दोनों ऑप्शन उल्टे करके देती तो कैसे मानती.
नहीं नहीं तो वो लोग क्लियरली बताते हैं तुम्हें कि ओरिजिन तुम्हें कहाँ रखना है
अच्छा.
बताएंगे
अगर नहीं बताएंगे तो क्वेश्चन रॉन्ग होगा ना.
फिर तो
और
क्वेश्चन
अगर
तुम
दोनों
और क्या आराम से क्लेम कर सकते हो तो तुम्हें फ्री मार्क्स मिलेंगे
ऑप्शन.
ये तो छोटी छोटी मिस्टेक्स ध्यान देनी होती है अच्छा तुम लोग को एक क्वेश्चन दे and now I'll give you an interesting question. Let's try solving it. Solve it. Everyone should get the answer. If you are not getting, I'll tell. I'll give you now an interesting question based on your knowledge of. I think you do not know torque now. Now you cannot solve this one. Later we'll. Did I tell you something about torque?
You don't.
I remember I told you something about torque.
Dot product of force and
No, that I told you, no?
something dot product of force into R or something. Yeah.
But leave it. You won't be comfortable now. The question is interesting, very easy one. Acha, let me show you. I'll show you the question and you tell
The
me.
center of mass will lie on the intersection point of the diagonals.
Here. No. No. Uh,
So for this question, can we consider A to be the origin?
yes, you can consider A to be the origin.
Since it will be 1, comma 0,
It will be 0,
0,
comma 0.
1.
A will be 0, comma 0. 2 will be, what is the length?
1 meter
1. So it will
size.
be 1, comma 0. 3 kg will be 1, comma
1,
1.
comma 1.
It will be 0, comma 1.
So now we could calculate the center of mass.
Easy.
That's what
You'll get the same.
We'll get the same answer. Whatever
Just
way
you
you do.
need the coordinates to be at a different point. Or the answer will be same regardless.
No. If you take different point as origin, you'll get different answer. Suppose you have taken 2 kg as your origin, then you'll get 0.5 and 0.7 only. In that case
Sir,
also
I
you
took
get
D as the
origin.
origin and I
if we
got
take, we'll get the answer same.
If you take 4 kg as 0, 0 or 3 kg 0, 0, you'll get different answer.
yes, sir.
Y coordinate will be different.
I got 0.34 y coordinate.
0.3 you'll get. That's why I said it depends. It depends which one you have taken as origin. You get the same answer if you take 2 kg as origin, but if you won't get the same answer if you take 4 kg or 3 kg as your origin. That's why I said what you're taking as origin. See this question. See this question. Do you have the idea? What is this? Internet is creating a problem, I think. Now okay, na? Am I audible? My voice is clear, na?
Yes.
Something happened. Actually, the internet. Now tell me. See, this is the question, and see whether you will be able to do it or not. actually in this, no knowledge of the knowledge of torque is also not required. Just the basic idea you should have, the when it will be, what will be the position of equilibrium, how it will be oriented.
C part over here, tan inverse of 1.
No, wrong.
Triangles over here. Proximity.
बताओ, आइडिया आ रहा है? कोई आइडिया ही नहीं आ रहा?
एक सेकेंड, जो आपने उनको फॉर्मूलाज बताए थे उससे बताओ।
देखो, इस क्वेश्चन में सिर्फ और सिर्फ एक ही नॉलेज लगने वाली है, सेंटर ऑफ मास निकालने वाली। इंपॉर्टेंट चीज ये है कि देखो, अगर ये इक्विलिब्रियम है ना, मतलब यहाँ इक्विलिब्रियम है, तो ये इक्विलिब्रियम पोजीशन है, तो सेंटर ऑफ मास जो है ना, सेंटर ऑफ मास
1/2।
अरे फाइंडिंग छोड़ो, वो सेंटर ऑफ मास जो है ना, वो इस लाइन पे लाई करना चाहिए। क्योंकि देखो, मैंने ये बताया, what I told you, that center of mass is the point where the whole mass of the system appears to be situated. Now there are three different rods, three identical rods. The combined mass of three identical rods will be somewhere. Suppose this is the center of mass. If I say here the total mass is acting 3m. Now if 3 mg is there, is it the equilibrium position? No, no. It will try to come here because you know a body, it's like, suppose a bob is there, the mass is like this, and you are saying, sir, the equilibrium position of this bob is here. Is it possible? No, na?
Hmm.
The equilibrium position is this, where the tension is getting nullified with mg. Okay, na? This is said to be the equilibrium position. This you all know. That point only I am trying to say. Means for this rod system to be in equilibrium, the center of mass of the system should lie in this, on this line. I don't know where it will be, but it will lie on this whole line. This is the concept. Using this concept, you must be able to get this angle. This theta you should be able to get now. So first you tell me where will be the center of mass of the system. I'll make it simple for you. I'll make a simpler diagram. The system that they have given is like this. three rods, this, this, and this. This is our system which is bent, which is inclined. All of them has equal masses, they are identical, and everyone has the same length. L, L, and L. Now you try to find out where the center of mass of the system will be. The hint is the center of mass of a rod lies at the center, meaning at L/2. Now proceed afterwards. So if you are not able to do, tell me, I will solve it. Giving you time to solve.
So, can you explain how to do this question?
See,
Sir, would even the y-axis distance be L/2?
yes, it will be L/2. The center of mass, na? Correct. But what will be the x distance? See, suppose how you do it. Suppose you consider the mass of these as m, m, and m because they are equal. The x coordinate of this, we take this as 0, 0, this point. So here the coordinate of this will be 0, or better, I'll take the bottom one because then we won't have to take negatives. 0, 0, this will be 0, L/2. The center of mass of this will be L/2, 0. Because this distance is L/2, na, half. This is also L/2. And again, this will be, the center of mass of this will be L, L/2. Now, if we try to find out the center of mass, x center of mass will be m into 0 plus m into L/2 plus m into L by 3m. M will get cancelled. What? 3L/2 by 3. 3 will get cancelled. X is at L/2. Meaning x is somewhere at L/2. Y center of mass, if we try to find, it will be m into L/2 plus m into 0 plus m into L/2 whole divided by 3m. Mm will get cancelled. It will be L by 3. So the center of mass, the position of center of mass is somewhere here. L/2, L/3. Okay. Now I'll give you a hint. This is a system which is just, it is kept like this, means it's inclined because it's in equilibrium. Now, where the center of mass is, I have said that this system will be in equilibrium only if the center of mass is lying on the vertical axis. Now, we know this from our calculation, this distance will be L by 3 and this distance will be L by 2. Now tell me, can you find out this angle theta? No, you should be able to do it. No. Hmm? Shyama, Haripriya, Diva, Radhika, anyone? Array, it's now easy, na? This is L by 3, so this will be L by 3. And this whole length is L, so it is L minus L by 3. It is 2L by 3. This distance. This is L by 2. This angle is what? Tan theta. Now we can, from this triangle, if I say A, this is C, let me say this is C, and this may be, assume this as P. Now this ACP, in triangle ACP, the tan theta that you will get is L by 2 by 2L by 3. L would get cancelled, it will be 3 by 4. So theta you are getting is tan inverse 3 by 4. This is your answer. Now ask me your doubts if you have any. And how was it?
So I
Hmm.
wanted to ask that if this was a perfect square, like if we had four rods, for example, then would the center of mass be like exactly in the center of the square?
Correct.
So it is only because we had three rods, this is why it's not like exactly in the diagram.
It's not exactly in the diagram. This is using this example, you will understand. See, when actually the center of mass shifts towards the more mass direction, means because these two lengths they have equal masses at equal distances, so the center of mass is lying exactly in middle. But when you come to top and bottom one, top mass is gone, it's not there, only bottom mass is there, so the center of mass will shift towards the bottom one. This is how you should get an idea about the center of mass. This idea will help you in solving questions quickly in your examination. Sometimes you can just predict using options. Okay, the rest all things you understood.
Yes, sir.
What about others? राधिका समझ में आया? राधिका नहीं समझ पा रही। राधिका बोल रही क्या पढ़ा दिया सर, क्या करवा दिया आज? What about Haripriya, Shama? You're able to understand this one?
Yes, sir.
Yes.
This was good one, na? So not difficult. Only geometry you have to find this one and then use geometry. Acha. So let me give you some more question, 1 or 2 questions. Then we'll move on to the uniform masses. Acha, then let me tell you a simple concept, not the difficult one. Motion of center of mass. So let me tell you about the next part, because the questions on this will be easier only. You will be able to solve easily. Center of mass of the uniform bodies. See, what I mean by uniform bodies, suppose I have a mass. Uniform bodies means mass is uniformly distributed. Now here this is a rod whose length is L. The whole mass is capital M. We say the center of mass is lying at the center. But how it is? How do we say like that? Because to find out the center of mass of a body, uniform bodies, what method we apply? The formula that we use is R center of mass is equal to integral R dm by integral dm. We make use of the integration. Means this formula actually, if we define according to the axis, it becomes x center of mass is equal to integral x dm by integral dm, or y center of mass is equal to integral y dm by integral dm, or similarly z center of mass is equal to integral z dm by integral dm. This I have taken all along the axis, along all the axis, but usually you will be using the formula, only these two formulas. But when you will be using these formulas, you will be using these formulas only when the mass is uniformly distributed. Means the masses here, see in this case, why we say mass is uniformly distributed? Because this mass is actually distributed along the length. Means some mass is here, some mass is here, some mass is here, some mass is here. We cannot pinpoint say that, we cannot say at some point it will be, the mass will be situated. In this particular case, what we do, how we use this particular formula, we actually consider an elemental mass of length dx. We say this as dm. Okay, and we assume some point such this is x is equal to 0, and we assume that it is situated at a distance of x from our assumed origin. Whatever, see what is our concept, we will assume, because the mass is uniformly distributed, we assume the elemental mass dm and treat it as a point mass, and then try to apply that formula, above formula, x1 dm, x1 m1 plus x2 m2 plus x3 m3, that thing that we do now, this x1 m1 plus x2 m2 plus x3 m3, that thing only we write like this, integral x dm. The meaning of integral x dm is this only, summation of mass and its distance divided by total mass. We do now m1 plus m2 plus m3. The meaning is actually we are dividing by total mass dm. We are dividing, integrating dm means we are summing the mass. So actually these two formulas are same only, but the way of doing them is different. So here in this particular case, what I have done, I have assumed the elemental mass dm and it's of length dx. It is situated at a distance x from our origin. So first we'll try to find out the value of dm. How? For mass, for length L, the total mass is capital M. For length dx, how much will mass will be? Capital M by L into dx. This is your dm. This is one way of finding dm. Other method is you can find mass per unit length. Lambda mass per unit length. This is capital M by L. Now you have found out using lambda, you have found out mass present per 1 meter of length. So for the length dx, how much mass will be there? It will be lambda into dx. It will be m by L into dx. Whatever formula you are comfortable to find dm, you can use that. Okay. Now you have found out dm. You will put in this formula integral x center of mass will be integral x dm by integral dm. We'll put the limits also. The limit is x is equal to 0 to L. 0 to L. This is 0 to L. X dm is m by L into dx. 0 to L dm is total mass. We are integrating total mass. Now m by L is constant, will come outside. Got cancelled. This is x square by 2, 1 by L, 0 to L. So it is L square by 2L. L will get cancelled. That's why we say the center of mass is lying at the center, L by 2. This method that I have told you is the application of this formula, integral x dm by integral dm, we use for uniform bodies. But the problem here is I have found out the mass per unit length here. But sometimes the question, they won't be giving this mass as a uniform entity. It will be varying with something. So in that case, the result will be different. Do you want me to give such question? Let me give that question to you. Just tell me, did you understand the concept or not? Everyone understood now? How to find out the center of mass for uniform bodies?
Yes, sir.
Now see, this is a question on this. Here, what I was saying now, that I have tried to find out in above case the mass per unit length, m by l. But usually, sometimes when they try to make the questions difficult, they give the mass per unit length is not same.
So
Here
we
in this
did
particular,
exactly same question, sir. But
where when in class.
yes, the same exact.
Because this is very common question, Shama. Because this question actually tells you about how if the mass per
How
unit
the
length is.
varying because it is in a function of x, it depends.
Then in that case, what you will be doing? Try solving this question. Just now try to understand this question. At home, you can attempt it. And in the next class, give me the result.
Okay.
Just try to see this one. If you have any doubt, ask me. Okay, now clear to everyone? Now attempt it at home. Give me the answer in next class. Okay, we'll end it. In the next class, we'll solve some more questions on uniform mass distribution. Then I'll tell you about the velocity and motion of the center of mass. There will be some interesting questions on this. The chapter is not much, but rotation part is more. Okay, let's end it now.